In this video, we're going to talk about dividing complex numbers. And we're going to start off with a rather simple example, 2i over 3i. Since I have all multiplication, 2 times I in the numerator, and 3 times I, or having all multiplication in the denominator, I of course can reduce I over I. We can't say that they cancel, they're not really gone, they just reduce to 1. And 2/3 times 1 is equal to 2/3. That's it. We just had to reduce that fraction. In this example, 1 over 3i, I don't have anything that can reduce. However, keep in mind that I is equal to the square root of -1. And as we all know, we are not allowed to leave a square root in the denominator of a fraction. So we're going to rationalize the denominator to avoid having roots or imaginary numbers in the denominator of any fraction. Of course, when we rationalize, we have to multiply by 1, by a value of 1, so we don't change the value of a fraction, just the look of a fraction. And in this case, we're going to use I over I. Since I is the square root of -1, wouldn't it make sense that we're going to use square root of -1 over square root of -1? So when I multiply straight across the numerators, a denominator, I get 3i squared. I squared is equal to -1, so I have 3 times -1 in the denominator. That gives me I over -3, and when I simplify, I get negative I over 3, or I could have put that negative in the numerator in front of the I value. 9i all over 3i. When I have a single term in the denominator of a fraction, I can actually take each term in the numerator and split them so they have their own individual denominator. This gives me, in the first fraction, 6 over 3 reduces to 2, or 2 over 1. And in the second fraction, I over I. And I'm left with 2 over I minus 3. My second tree, but taking a look at 2 over I, oh, there's my nasty root in the denominator. So I need to rationalize the denominator of my first fraction. Multiplying by I over I get 2i over I squared. 1 simply gives me -2i. I can't leave my complex number as -2i minus 3. I need to, of course, put it in the correct order to be a complex number. Lastly, let's take a look at 1 minus 5i over 3 plus 7i. If I multiplied by I over I'd end squared. It would not get rid of all complex numbers or imaginary values in the denominator. So this time it's going to look a little different. Instead of multiplying by I over I'm going to multiply by the complex conjugate of the denominator. Anytime you have a full complex number with both real and imaginary parts in the denominator, I'm going to create my multiply by 1. That means that I'm multiplying 1 minus 5i times 3 minus 7i in the numerator, and 3 plus 7i times 3 minus 7i in the denominator. We've already discussed how to multiply complex numbers, so I'm not going to go through all of those steps, but when I do all the distribution, 7i minus 15i plus 35i squared in the numerator, and 9 minus 21i plus 21i minus 49i squared in the denominator. We know that I squared is equal to -1, so I'm going to go ahead and multiply 35 and -49 by -1. And now I'm going to combine like terms. In the denominator, I have 21i minus 21i. Those two terms are going to cancel and add to 0. That's going to happen anytime I multiply a complex number by its complex conjugate. So combining like terms leaves me with negative 32 minus 22i all over 50. This is a case where I have only one term in the denominator, so I'm going to split each term in the numerator, and now I can do a little more reducing. Reducing my fractions gives me negative 629i. On a side note, since our denominators I could have left it as negative 16 minus 11i all over 29 are correct, and they're the same fraction. Write down any questions that you have. I hope you have a great day, and I'll see you in class.